Hi, my name is Jack Reed. I'm a software engineer at Stanford University, along with my colleagues Chris here and Jessie, Keck. And we want to talk about adding services to your repository to help adoption, actually meet researchers where they're at and doing research. So we'd offer the proposal that offering open services drives adoption and use. We're going to give some specific examples during our talk today to talk about what these open services are and how they've driven adoption and use in our repository. So Stanford researcher Kenneth Schultz submitted this paper, Mapping Interstate Territorial Conflict. And so the paper was about mapping this conflict. And so of course there's probably data that goes alongside with that. And he submitted the data to our repository. And he had this great quote: putting the shapefile on Earthworks and linking to several derived data sets on the Stanford Digital Repository not only allowed me to make the data available to interested scholars, it also helped me meet a requirement for publishing that article. And that's a great thing, right? That's what that's kind of the promise of digital repositories, is that not only is the data published, the data is available, and it also meets that funding requirement. And that's a great role of a repository, and I think that we want to meet that use case all day, every day. But one thing about that is, though, we just meeting that funding mandate or funding requirement isn't always enough. And we're not always going to know the best way that researchers want to use this data, or the general public are going to be able to use this data. And somebody else is probably going to think of a new and innovative way to use this data in a way we never could have.
So our first example is from a collaboration between CESTA, the Center for Spatial and Textual Analysis, and a group now called CIDR, the Center for Interdisciplinary Digital Research, who are part of the library, we're not part of the digital library group that runs the repository. And what they do is work with faculty on special projects doing digital humanities. For example, this City Nature project, where they looked at green space and how it affects a number of different variables. In the end, I think they determined there's no macro level impact for green space. It doesn't affect income or ownership, but there are localized distortions. And they put together a whole bunch of interesting visualizations of this data. Okay. For example, in LA, they were able to map where parks are and compare it to different sets of demographics. And it's a very interesting project. It's all, you can navigate around and see different cities and see different aspects of the data. Visualizations built with a variety of technologies, GeoServer, ArcGIS, and D3. And typically, this is the end product of a digital humanities thing, right? You have a website, you go to it, you look at it. At the end, we're fortunate in this case we were able to go a little further and get them to self-deposit their data into our repository. Carl was able to go and put the CSVs, the code books, and all that into the repository for us, allowing us to preserve it and also make it accessible directly outside of the scope of just the website they built, hopefully ensuring its longevity and usefulness for other researchers. And we can already see how that functions. Because they self-deposited it, it shows up in Earthworks, our geo portal, for data such as this, where it's discoverable, and there's some really great tools for analyzing within the application. And also SearchWorks, our general library catalog, where you can go and actually download the data and codes. And the important thing for researchers is then you can get the data, you can see the CSV file, and actually reuse it. A researcher can come along and use, say, R, and pull the data in directly from our repository. They don't need to download it. They can actually start using it right away, which is really exciting. It seems very trivial, but the fact that you can go out and pull data from many different sources, combine them, is the whole point of research. But not just with local tools, you can also, because this is very easy, there's an access control allow origin header that we've added to our digital stacks. And what that, just one little line does, it allows you to work with this on the web. So instead of downloading and manipulating it locally, you can use, for example, blocks, which is kind of deep free hosting system, really lovely lightweight service. And you can manipulate it, you can share it. The code for all this is open. So if you've got similar data sets, you can already see how you can take it, apply it to either similar data sets or take these visualizations and apply it in other contexts. With the added advantage of this little block up there is also embeddable. It's just an iframe. You can take it and put it to your own websites and share it around. And the data is coming from our servers, which means when the researcher may version their data, they may get new data was collected in 2013, I think. If new data came up, it would automatically appear here, which you can't say for actually write a paper.
Roll this microphone. Another thing, in addition to what Chris was mentioning with allowing direct data access, another things that we can do or services that we can add to drive adoption. So this is a spotlight exhibit you can see here. The collection that we're showing is a photo archive from a photographer named Bob Fitch. We received this collection under the premise that we make 5,000 of the most iconic photos from this collection available online. These are mainly focusing on 20th century social justice and civil rights movements in the United States. So our ability to make these photos available online was a driving factor for us to receive this content, therefore driving adoption of the repository even from outside of the university community. The ability to deliver and make content discoverable drives repository adoption. In addition to making the content available online through our digital stacks, we have also created this exhibit that we're showing here. Spotlight's an exhibit building framework built on top of Blacklight, if you're not already familiar with it. This allows curators to easily organize and describe the content in new and interesting ways. So I'm just going to kind of show a couple interesting things we've done, the curator has done here. So as you can see, that this has been, they've organized a subset of the content and added a narrative that you can see kind of above the images. It probably isn't come well on the projector up there. So they can create these categories, add a narrative for particular content, and this facilitates the discovery of these objects. So more than just allowing the images to be available online and downloaded, we're creating an entire service around being able to actually use this information in interesting and innovative ways. And one thing you can see here, so in Stanford's implementation of Spotlight, we use our OEmbed service. So you can see the image here on the left. And this handles the viewing and the full representation of our objects. What this allows us to do is we don't have to concern ourselves in our various environments with which viewer we want to use. Should this be a file list? Do we need to bring in a image viewer or a media viewer? So we get to completely ignore that, and we can just identify things based on their identifier in our stacks. So what you see here, we're getting served up an image. It's using our IIIF infrastructure. And I mentioned IIIF because that embed service is something that we've built, that we use locally at Stanford. What you're seeing here is an instance of Mirador, where we've taken that exact same IIIF manifest, pop them in here, and now we're actually able to pull up side-by-side images, do comparisons. Mirador is a very powerful tool. It has lots and lots of different features. And it's all built on top of IIIF. So once you've implemented IIIF, you get to get these services for your data completely for free.
And so kind of the last story we want to tell is about it started with an outbreak in Zambia, cholera, in February of this year. So there was a large cholera outbreak in Zambia, and we were contacted, or the Stanford Geospatial Center was contacted about some data they were looking for by MSF, Médecins Sans Frontières, or Doctors Without Borders. They were using Earthworks, which is our geo-blacklight discovery portal for GIS data, and they found some data on Zambia that they needed to use to make some maps. And the data was restricted, and so they contacted our center. They said, "Hey, we need help with making these maps, and we're looking for this data." Our geospatial center was able to respond and talk with them and actually find some additional data from a Stanford researcher. And MSF was able to create the largest ever oral cholera vaccination campaign and start to vaccinate over 500,000 people in Zambia using this data and using some of the maps created that they originally came to find in Earthworks. So Stace Maples, who's the director or the manager of the Stanford Geospatial Center, went to a WHO Global Task Force on Cholera Control meeting in London earlier this year, and met with the head of mission at MSF. And this is her showing him the maps that they actually created using that data that they found in Earthworks in our repository. So this is a really powerful example of discovery, discussion kind of with the library and repository team, and being able to add data that couldn't actually been found anywhere else from a Stanford researcher repository. Stace went on and wrote a great blog post about this, that with more details kind of about all the intricacies here. But because we have an embed service like Jessie mentioned, for all of our data in our digital repository, in his blog post, he's able to embed a map of the data that's actually used in this cholera outbreak response in the blog post, with the ability to download it and grab it. And this is being served out by our embed service, but the map data behind it is being served out by spatial data web services behind all of them. Now, these spatial data web services have been around for a long time, but they may be kind of new to the repository community. Two standard specifications, web mapping service and web feature service, are used all over the world to serve out map and geospatial content. So these are great services that integrate with a lot of different software and a lot of different other software and service applications, including GeoBlacklight, we showed, OEmbed, which is our service there, and desktop software. So I'm going to show that real quickly here. This is the open source GIS software called QGIS, and the same exact data that we showed in the OEmbed service is being served out from that WMS web service. I'm saying service a lot. But it's imported directly here into this desktop research tool. A researcher can use the data that's coming directly from the repository in their own research tools to create maps, do analysis, export out into different formats, and really do whatever they want with it. And this wouldn't be possible without these services coming from the repository. The previous, the workflow previously would be kind of like scour the web for all of this kind of data, look for it in a lot of different places, download a whole bunch of stuff, and then maybe bring it into my GIS application and try to use it. See what's usable, see if I can actually use this thing for what I need to do. You know, with a couple clicks now from this hosted service, you can download and use this data. Another great point of integration is with a product called CartoDB. It's an online mapping and visualization software. In the GeoBlacklight software project, there's a button now called Open in CartoDB. CartoDB is an open source software application with an import API, and we're able to import data into it directly. So from discovering the data in GeoBlacklight, the researcher can click one button and import it into a visualization application, and then create the maps that they need to use. So this map here, check it out. The same map that we've been looking at, same map that the MSF is using for their Colorado response.
So this is something that many of you guys have probably seen before. This is the data lifecycle. And this is an interesting quote from the site that we've linked here that we thought we'd mention. So data often have a longer lifespan than the research project that creates them. Researchers may continue to work on data after funding has ceased. Follow-up projects may analyze or add the data, and data may be reused by other researchers. Well-organized, well-documented, preserved, and shared data are invaluable to advance scientific inquiry and to increase opportunities for learning and innovation. So we all know this. This is very common in our day-to-day life, yet a lot of the communities that we're a part of and conferences that we go to, it seems like there's a very big focus on creating data and preserving data. Some of the areas that it seems like often get missed, or maybe there's not as much focus on as there really should be, is some of these other areas like processing, analyzing, and I think most importantly what we're talking about today is reusing this data. The data reuse from our repositories I think is hugely beneficial for our researchers, and is, like Jack was mentioning in the previous kind of paradigm of downloading and taking all these different pieces and needing to do generate your research like that, is splintering the data in a way, and having it all centralized and being able to keep it in the repository gives us a little bit more control. So, you know, a lot of these things seem a little bit daunting, but accomplishing this is absolutely doable, and more so when you're using a suite of open specifications and open source software. This allows for seamless integration into your and your researchers' existing technology. So a bunch of the stuff that is on this list are things that we've been showing you today. You know, cores being an extremely important thing that the cores header that Chris showed to make sure that this isn't only us that can use this data. Anybody from outside can use the data, and they can use it from JavaScript clients right in their browsers. You don't have to have a server set up to download the data and serve it. You can do this in plain HTML. And you guys are probably familiar with lots of this the software. We've been talking about a lot about these open source software packages in this community and various other repository communities for many years now. So, building value-added services that allow researchers to build on top of your existing library infrastructure lowers the barrier to entry to using your data. It brings the data to where your researchers already are and reduces the splintering of useful information that your researchers would otherwise need to stand up and maintain themselves. So let's not just create an open repository, but let's build open services around the repository. Thank you.